I went through City College San Francisco to get my associate's degree or whatever a couple years ago. And I've also given past talks at BSides the last couple of years in San Francisco, BSides LA, New York, NASA Ames, and a couple other smaller conferences. So we're basically going to go over some of the more prominent variants that we've seen in the last couple of years of ransomware, some of the vectors of compromise from it, the C2 setup and the design that they use, and kind of like what we've done in the past, and a little bit of the current aspect for tracking and knocking these things offline. You probably have some questions about stuff that's really current, and I might or might not be able to answer them due to like day job and what we do there. So if I can't answer your question, sorry. So we'll kind of take a step back here and look at Revitin. It's kind of like the old school, what you used to see back in the day, ransomware. Basically, it would come on and infect your system, give you this little pop-up screen that said it's from the FBI, looked all official looking, had a little your IP address and the web camera along with it. The thing about this one was that it wasn't really ransomware. It was basically just a lock screen that would come up on your system, and it was really easy to take off by going into safe mode and just removing the virus from the registry. There was actually a couple of people who, I guess, turned themselves in to law enforcement at some point in time. I think it was legitimate, so, you know, it kind of worked for the better good, I guess. Now, as we all know, probably CryptoLocker, pretty much the biggest guy that came out swinging there in about 2013 or so. It was like the first one that actually came through and encrypted your system using like a 2048-bit RSA encryption key. And it's also essentially what every locker infection is now referred to, even though no one uses CryptoLocker anymore. So, as I was saying, we started to see it, and, you know, towards the end of 2013. Mainly, it was delivered through the Game Over Zeus botnet, and it used DGA, so a domain-generated algorithm, which is basically like a bunch of letters and numbers smashed together to create a domain name. Not usually something that you would type in by hand. It would create thousands of these domains at once and actually only register one of them to actually be the C2. The point of it was essentially, and this is what kind of one of the domains looks like, was to put a bunch of domains out there to kind of make it harder to find the C2 in the list of them all. And can anyone actually spot the really bad part of this domain here? Huh? Yeah, that's right. Doesn't have anything to do with the DGA, really. Anyway, so in like mid-2014, so about June of that year, the Game Over Zeus botnet was taken down. Basically, that took down CryptoLocker with it, and it also allowed the decryption keys to be surfaced by like the FBI, whoever took it down. So it allowed anyone that was still encrypted with CryptoLocker to essentially decrypt all of their files. Right around the exact same time that CryptoLocker went down, we started to see new variants emerging. One of these would be Torrent Locker. So Torrent Locker was mainly seen in like Australia, New Zealand, and certain parts of Europe. And it was mainly sent through phishing emails disguised as either red light tickets or tax notices. Looks something along the lines of this. One of the things that they did, though, which made it really easy to knock it offline, was they used a really common naming convention for all of the C2 domains. And it usually worked out somewhere in the realm of like a Oz or NSW, which is like the New South Wales, and then post or gov, and then org, biz, net, info, one of those TLDs. So as you can see, the examples like database, -nsw, -gov, .org, and ozpost.com. They're mainly meant to look like official-looking domains, but they're not. But it was really easy to mass block these because we essentially knew what their naming convention was. So it wasn't really a threat, for the most part, to a lot of our client base. Moving forward, you started to see like Alpha and Tesla Crypt. So basically, this started out attacking your video game extensions. So gamers would get all their files encrypted. But then they started to use, or in the beginning, they were using like another DGA-based domains for the C2s that essentially look something like this. So the subdomain is a bunch of letters smashed together. The domain's, you know, a bunch of letters and numbers smashed together. Once again, any type of like lexical analysis on these domains edit distance and stemming and all that will easily detect these in any query stream and any network. So it's kind of a error on their part. They changed this in later versions and started to use more of a compromised website approach to go about it. So this kind of helped blend in a little bit better from your network traffic. And essentially, this is your standard TeslaCrypt lock screen. And then the first version of TeslaCrypt, they used a symmetric AES key that allowed Talos to basically put out Tesla Decrypt. Unfortunately, once you put something out like that, the malware authors just fix their flaws like anything that gets put out there. So the next big one that we actually saw was CryptoWall, which is kind of more the recent mid 2014 to 2000, about the end of 2015 is when it was really big. I guess 2014, whatever. So basically, CryptoWall, though, instead of using DGAs, what they did was they compromised servers, usually through WordPress, most likely through like the RevSlider plugin, which allows you, had a vulnerability that allows you to extract out the database with all the login ID and the password. And then they also started using Tor and I2P, which I2P, if you don't know, is the invisible internet privacy or something like that. But it's basically another anonymous, hide your real location service. So the exploitation. There's a whole group of a big number of events that could happen, but most likely it's either through phishing or a compromised domain or malvertising. What essentially happens is you have your user who either gets the phish or they land on a web page that either has injected code into the page or some type of malvertising that sends them to an exploit kit. Then once they get exploited, in whichever way, then there's a call out to the raw IP, to get the raw IP address returned for the location of the user, and then that's put in, as we'll see in a minute, into a encrypted hash that basically goes to these sets of servers, and there's usually, 5, 10, 15 of them that they try and reach in case one gets taken down. And then behind those servers, there's calls to the Tor and I2P networks. This is kind of and this is actually like a real, kind of like log of what it would look like to be, like you would see in your stream from an infection. So essentially, this is your exploit kit firing off, which is Angler. You can tell by the subdomain. And then you have a call here to the raw IP address, so IP-address, ES or whatever. And then all of these are all of the compromised domains that actually host the binary. So one of the cool things actually was this little part right here. In every single CryptoWall sample, there's always a call to a raw IP address. It's either this domain or myexternalip.com or curlmyip. And they do this essentially for geolocation. And there's a couple reasons that they do it. One is, depending on where you're at, so pretty much anywhere in Eastern Europe or some parts of Iran, I believe, the encryption won't happen because they basically don't want to infect themselves or their family or whatever reason. And it also was to display the ransomware message in the native language of where you're at. So if you're in America, it's in English. If you're in Spain, it's in Spanish. It's, you get the point. The other part of it is that it creates a unique identifier. So it's added to the hash with the other system info. So basically, it looks something like this in a post request. So it's basically the requesting ID, the campaign number, the MD5 of the system altogether, and then the OS info, and then the IP address attached to it. And this is all sent to the C2 to basically fingerprint the system. It's also so they can only make it so like one IP address gets infected at a time, so it makes it harder to research what's going on. Exactly. So as I was saying, there's three primary domains that we use: the IP address, the curlmyip, and myexternalip.com. IP address is actually the main one that was always used, and the other two were just used as backups in case for some reason IP address couldn't be reached. So this is actually really cool because while they were being really nice, it gave us a really cool indicator to kind of go by. Because we basically, could go to someplace like malware.com, right, and do a search for the domain IP address. Well, essentially, what it would do is give a return that you see in a minute, but there's no real usable API with malware, so it gets a little rough to do this manually all the time, which we'll go into here in a minute. But essentially what you end up with is a list like this. And this is all the files that like malware.com has that have IP address and the network information, right? So if we take a look at, there's our term for the domain. And then if we see the antivirus scores, these are, I mean, if you look at it, it's clearly bad. But even like some of the antivirus engines weren't detecting these attachments or whatever as malicious. But if we go and we take a look at this guy, we'll see, there's our IP address, and then it's pretty clear that making these calls, much like the slide that I had earlier, all the domains where the malicious binaries are stored. So another thing is VirusTotal, of course, and I'm pretty sure that most of you are familiar with VirusTotal. So essentially what we were doing in the beginning was like going to malware.com and like typing an IP address and like finding all the domains that were bad. But it's very tedious, and I basically didn't sleep for a couple months. So then I started to use VirusTotal, and there's another part of the VirusTotal called VirusTotal Intelligence, which is the back end of it. The VTI allows you to do some really cool stuff like this. So you can create a set of URL rules, essentially, for anything you want, and basically any sample that VirusTotal has, either retroactively or new, you can go back and find. So I created a set of rules that basically look for any sample that made a call to any of the like main raw IP addresses, and you'll see ipinfo.io at the bottom there, and that was mainly what Torrent Locker was using at the time. I don't know why they changed from, different actor group or whatever. But the cool thing is you can set up like a running JSON or RSS feed about it, so you can get notifications when all these come in right away. But then again, you also have to pay for VirusTotal Intelligence, and it's not inexpensive. So it's not always a cost-effective means for smaller companies and stuff. But if we take a look, we can see so these are some of the rules that got hit on. My rule set's generically named, but you can tell by so rule 4 was IP info, right? So I knew that it was like Alpha Tesla Crypt. I knew this was crypto wall because it hit on the crypto wall IP address. And, through various rules, I could basically identify all of these exponentially fast. So if we look at this guy, basically in the file information, once again, we can see like the full URL paths for where all the binaries are stored. They make it seem kind of nonchalant. But as we can see, here's another call to our raw IP address return. And then the crypto wall binary C2 domain. All this works, but it's still kind of like a really slow and tedious process, and very manual. So it wasn't really efficient for real time. So eventually what we do in kind of like the DNS world, we can kind of pair domains together using a couple sets of terms. One is co-occurrence and the other is related domain. So a co-occurrence basically happens when someone queries a domain. Like think of it like if you land on like Google and all of the requests that happen in the background is basically a co-occurrence. So anything that like basically, you query one domain and there's another domain like this that happens right off the bat. A related domain is one where they're queried in almost the same time frame, but it's a little bit more spread out. But, we're talking milliseconds at this point. So this is kind of like a look of like one of our internal tools that we have of the actual IP address, .com domain. So the top of it is basically like DNS queries per hour over the course of whatever time frame that is, like a couple weeks or something. But as you can see, so there's all these related domains down here. Legitimate websites will actually use these raw IP addresses for all sorts of things, mainly like updates to find the nearest server or whatever. So one of the problems that we had to get through was basically creating a script and then training it to not block any legitimate domain. So we kind of had to sit there, and I'll show you the kind of generic pseudo algorithm we came up with in a minute. But we had to basically train this so that we could auto-block all these domains that were basically being seen that were queried right around the same time as IP address. Because eventually, once we built up the training set, anything that was called out to that domain afterwards was essentially crypto wall. Like our FP rate was like 0.05%. So essentially, we used it as a pivot point to find all the other domains. And the great thing is that this particular one is actually the least noisiest of all the raw IP address domains that there are. Like the other two that I was mentioning earlier are super crazy loud. I mean, like we're talking like, you know, millions of queries an hour by extremely legitimate domains from like NVIDIA to Weather Channel or whatever. So it made it really easy to build up our training set about what was legit and what wasn't, because most of the legitimate companies don't use this particular one. So it was really thanks, really. They couldn't have made it any easier, really, at that point. So this is kind of like a blown up version of the bottom section of that last slide. As you can see, there's like the first two related domains are the other two raw IP addresses that I was talking about. And then we have like some Microsoft, some more Microsoft Drive, some Google stuff. So eventually we basically had to build up like a whitelist to make sure that these things like didn't inadvertently end up in our GBL. But the great thing was that like after we essentially built all of this up and identified all of the good domains, we ended up with essentially all of these domains. All of these are actually crypto wall domains. So we're basically able to identify these within, you know, seconds of actually being seen. So essentially what we did was like we had a script that ran against the IP address, and then we were like, have we seen this before? Have we not seen it before? If we hadn't seen it before, then we would get a notification to the analyst team that there was new domains in, and then we would go and validate by looking at the traffic to see if it was legit or trying to find the actual binary on the system. And then if it was bad, we would block it. Basically, the training set gets updated, and the more that we did this, the less that there was human involvement going on. And eventually, it became a completely automated system where, you know, over the course of whatever day or week or whatever, we would just automatically, within seconds, find and add them into the GBL. But the real thing is like removing the false positives out of it, and that was actually the time-consuming part. It took probably about a month of manual processing to train it so it could run on its own. So this is basically what the traffic patterns look like to compromised domains. So as you can see, like these places aren't really that busy up until like this point and this point, like right in there. Like they start to get more traffic, and then that's where the calls are going from the redirects from infected systems. And as you can see, like moving, you know, this way, like it definitely increases. And you can also see that the traffic is almost identical running from both, and that's because, you know, they're from the same sample set. So pretty much mainly